Welcome back to another exciting chemistry lesson. In this video, we are going to learn about chemical formula. Now, a chemical formula is a shorthand method of describing a compound. Well, it uses symbols of elements which are on the periodic table, subscripts, and sometimes parentheses. Well, let's look at the example, or examples, in this case, to understand how are subscripts and parentheses used in a chemical formula. First of all, if we look at this compound here, and we notice there are three elements, which in this case sodium, nitrogen, and oxygen. Because Na does not have a subscript, we assume it has to be 1. The same thing for nitrogen, it doesn't have a subscript, so we assume it's going to be 1. So in this case, we have one atom of sodium, which is Na, and one atom of nitrogen. But for oxygen, there are 3 oxygen right there. So 3 oxygen because of that subscript 3 right there. But not only that we know about the atoms, but we also know about the ions. In this case, we have Na right there, that is sodium plus. And we have NO3, that is one of our polyatomic ions, which in this case, NO3 minus. So we have 1 and 1 of that. Now let's look at how this one is very similar to this one, but in this case it has parentheses in it. Well, we assume that this must be 1 right there, so we have 1 atoms of calcium. And what about the parentheses right here? That tell you this 2 right there, that number outside the parentheses tell you that there are 2 of this. So 2 of whatever inside that parentheses. So that means there are 2 of NO3. Okay, specifically it's going to be 2 of NO3 minus charge. That is the polyatomic ions. So how is that going to affect our counting of the number of atoms for each of element in the parentheses? In this case, if there are 2 of this, that means there are 2 of nitrogen, so we're going to have 2N. And what about the oxygen? Since there are 3 of them, what is 2 of 3? That means 2 times 3. That means there is going to be 6 of oxygen. You see how that works? So you basically type this number times the subscript for each of the element inside the parentheses. So again, be careful with the parentheses. That number right after the parentheses tell you how many of the inside of the parentheses is going to be. So be careful with that. Well, in this case, we have 2 of the ions of NO3, which is nitrate. What about how many calcium ions do we have? So it's just going to be 1 calcium with a 2 plus. And that is how parentheses are used in a chemical formula. Let's look at another example. In this case, we know that subscript tells you there are 2 atoms of sodium. The sulfur does not have a subscript, so we assume it's going to be 1, so 1 atoms of sulfur. The oxygen has 4 because of the subscript is 4, so therefore 4 oxygen. And then if we want to identify the ions, this is 1 ions right there, which is 1 Na. Well, in this case, not going to be 1, it's going to be 2 Na plus. What about SO4? That is actually an ions of SO4, 2 minus. So this is a polyatomic ions. In this case, how many do we have? We just have 1 of SO4. Now let's look how this is going to be different in a chemical formula with parentheses. In this case, we have aluminum, so that is going to be 2 atoms of aluminum. But again, we have parentheses, and outside that parenthesis is a 3. That means there are 3 of that, whatever inside the parentheses, right? Which is 3 of SO4. So how does the number of sulfur and oxygen going to change? So again, we have to multiply the subscript. In this case, 3 times 1, which indicate there are 3 of 1 sulfur, which is give us 3 sulfur. What about 3 of 4 oxygen? Because of that 4 right there, what's that going to be? Or 3 times 4, that give us 12 oxygen. And that's how we interpret the chemical formula with parentheses and the number outside that parentheses. Now let's look at in terms of ions. Of course, we're going to have this ion is going to be Al3+. That's from the periodic table. This is group 3A. So this is going to be 2 of that ions. And what about the sulfate? Of course, for sulfate, it's going to be 3 of that sulfate ions, which is 3 of SO4 2 minus. And that is how we interpret the subscripts and the parentheses in a chemical formula to determine how many of that atoms or ions of that specific elements or that specific ions, either monatomic or polyatomic ions.